All right, so we'll finish up what we're going to do for Chapter 8 this week with 8.4, which is still writing complex numbers in trig form, except we're going to learn how to raise numbers to powers, which is called de Moivre's theorem, and then how to take roots, okay, which is the opposite of raising to a power. All right, so let's take this number in trig form, and I want to raise this to the second power. Okay, and the first time, we're going to do it. We're just going to distribute, FOIL, multiply everything out, and then see if we notice a pattern. All right, so what does it mean when I have z to the second power? What does that mean to do? Yeah?
Multiply z by itself.
Yeah, it means to do z times z, multiply z by itself. So I have r cosine theta plus I sine theta times r cosine theta, I sine theta. So really here I have four factors I'm multiplying together. There's 1, 2, 3, 4. And I'm multiplying those four things together. So two of them I can multiply together pretty easily. In fact, the first and the third factor. What do you get if you multiply r times r? You get r squared. And now the rest of it would be like a FOIL. Okay? I'm not going to rewrite it, but pretend that we've taken care of that and that, multiply what's left. Okay, so we need to do cosine times cosine. And then we have cosine times I sine, and then cosine times I sine again. So how many of those are we going to have? 2. 2 of the cosine times I sine. So let's write that as 2. Where do I want to put the I? Yeah, you can put it wherever you want. I'm just trying to think of the easiest way. I think I'm actually going to put it in front. So I times 2 sine cosine. Okay? I could have put cosine sine, but I put it as sine cosine for a reason. Hopefully you'll recognize that in a little bit. And then lastly, I have I sine times I sine. So that's going to be I times I is I squared, which is a -1. And that's sine times sine, which is sine squared. So it's really a -1 sine squared. Or you can just write negative sine squared. Any questions on foiling or distributing that out? And now I'm going to rearrange it. And at this point, we just need to recognize a couple trig identities in here. So I'm going to put the cosine squared and the minus sine squared right next to each other. So cosine squared minus sine squared. And then I'm going to put the middle term on the end. I times 2 sine cosine. Sine cosine. Okay, there's 2 trig identities inside the parentheses. Does anybody recognize or remember what cosine squared minus sine squared is? And it's not the same as sine squared plus cosine squared, which would be 1. Okay? But there is an identity when it's a minus. And we did it, I think, in section 7.5. Let's see. Yep, it's right in section 7.5. So if you have your notes or you have your books, see if you can find the formula in there somewhere for cosine squared minus sine squared. What does cosine squared minus sine squared come from? Yeah. That's the sine squared plus cosine squared. So the plus one is a Pythagorean identity, but this one is not. It's a different, it's a double angle identity. Yep. So what double angle is that? Nope. Okay, so what would you write down? That is cosine 2 theta. So cosine squared minus sine squared is cosine 2 theta. What about that last part, 2 sine cosine? Yep, so what would you put there? That one is sine 2 theta. And that's what you get when you square z. So now I want to look at this and look at what we started with, right here. And I want to see if you can tell me how I can get from this right to that without going through the steps in the middle. What's the pattern when we squared it? And then we'll look at the pattern for cubing. Noah? Yeah. So you raise the radius to the power, and you multiply the angle by the power. Yeah, there's some connections with that. Yeah. So it's a little bit different because when we're multiplying complex numbers, we add angles. When we're dividing them, we subtract. In this case, you multiply the angle. So we haven't done that yet, but it's kind of similar. So what about z cubed? Mag?
Will be r the third of parentheses cosine 3 theta plus I sine 3 theta.
Yep. So in general, the pattern is raise the radius to the power, multiply the angle by the power. Right? And that's a lot easier to do than if I said to take something like this and raise it to the 12th power. Because now you would have to write 2 plus 6i 12 times, 12 sets of parentheses, and you'd have to FOIL each one at a time, and then combine all your like terms. If you want me to write this in trig form and then raise it to the 12th power, it's going to be a lot easier. Just raise the radius to the 12th, multiply the angle by the 12th. Sometimes the radius gets pretty big. So if your radius is going to be a number in like the thousands or tens of thousands, a lot of times we don't do out the exponent. Okay, we just leave it as like, let's say the radius was 5 to the 16th power. We just leave it as 5 to the 16th. Okay, because it'd be pretty big to do it out. Okay, so this formula is called de Moivre's theorem. And it works for raising complex numbers to any integer power, squaring, cubing, things like that. And it's important to know how to raise to a power because when we're taking a root, this is part of what we have to do. So raise your radius to the power, multiply the angle by the power. This is definitely the easier of the two operations today, okay, raising to a power. Any questions on the formula for de Moivre's theorem? Okay, and keep in mind, we didn't prove this. We did one specific example, squaring, which suggested a pattern which turns out to be true. But we did not prove this. Okay, so I want to cube that number. What's wrong if I want to cube that using de Moivre's theorem? It's not in trig form. So that's the first thing I would have to do. So my radius would be 1 squared plus the square root of 3 squared, and then take the square root. So yeah, 1 squared is 1, Square root of 3 squared is 3. 1 plus 3 is 4. And then take the square root. Okay, that's the kind of stuff we went through yesterday. So your radius is 2. And my angle, I might need a calculator. How would I get that? Yep, of? Yeah, and this time you don't need the 180 because you are in quadrant 1. Okay, and anytime you have a square root in the answer, it usually comes out nice. So inverse tangent, square root 3. I don't even need to put divided by 1 because it doesn't change it. So my angle is 60 degrees. So now the arithmetic I'm going to have to do is with numbers that don't have any decimals. So it should be relatively easy to do this in my head. Whereas cubing this in my head, trying to multiply, let's see, 3 sets of parentheses in my head, that would be hard for me to do. But not this one. So now I've got 2 cosine 60, I sine 60, and we're going to take and cube that. So when I cube it, what's going to be my radius? And this is small enough, I'd like to do the radius out. 8. Yep. So the radius is 8. And my angle is going to be how much? Yeah. Angle times 3. So 60 times 3, which is 180. Okay, and that's the final answer in trig form. Now, if they wanted the answer in standard form, how would you get the real part? Yep.
Multiply 8 times the cosine of 180.
Yep. You do 8 cosine 180. And that would give you negative 8. Plus, how would you get the imaginary part? Yep, 8 times sine 180. And just don't forget, we've got to put an I after that. Yeah, sine of 180 is 0. 0 times 8 is 0. So what happens when you do 0 times I? Yeah, there's no imaginary part. So if you want to write this one in standard form, all you get is negative 8. If you want to write it in trig form, it's 8 cosine 180, I sine 180. Yes. We're going to talk more about how that connects in, but that's exactly the question that you just said. I'm going to ask exactly that question in a little bit. All right, so I want to find that number raised to the 8th power. So this is getting to the point where you couldn't even probably do this in standard form because it would take so long to really do it out. So let's start with my radius. What do you get when you square negative root 2 over 2? Well, when you square anything, you always get a positive. One? Well, I'm squaring it because I'm doing the Pythagorean theorem, in case there's confusion there. So we've got to square this. Square the top. What do you get? In the bottom? What's 2/4? 1/2. So I heard 1. A couple people said 1. So that part's a half. Plus, now you're squaring the same thing again. Just as it doesn't have a negative, but this negative doesn't matter. So it's half. So add them up and take the square root. So r is 1. So this time the radius doesn't even really matter. Okay, it's a 1. And then my angle. Well, the real part and the imaginary part are the same. So that means the angle is a multiple of what number? It's a multiple of 45. And you're specifically in the negative positive. You're in quadrant 2. So what would be your angle? Yeah, your angle is 135. Okay, if you weren't sure, you could do the inverse tangent of y over x, but that's going to be the inverse tangent of negative 1. You're going to get negative 45, and then you would have to add 180, because you're in quadrant 2, and you would get 135. Okay, so the only reason I could do that angle in my head quick is because the real and the imaginary part were the same absolute value. All right, so now I can write my answer. I don't need the 1. I can put it. It's not necessary. And we're raising that to the 8th power. So what's my radius going to be? 1. It's 1 to the 8th power, it's 1. And what's the calculation for my angle? Yeah, it's 8 times the angle, so really it's 1,080. But we usually write our angles between 0 and 360. So what can I do with that?
Subtract 360, so you get it.
So really it's the same as a 0-degree angle. Cosine 0 plus I sine 0. So that would be your answer in trig form. If you wanted it in standard form, what's the cosine of 0? 1. What's the sine of 0? 0. So what would you get for that answer? 1. So if we raise this to the 8th power and we got 1, then what that really means is this is an 8th root of 1. It would be one of the 8 answers. Okay? When you're finding roots, there's as many answers as there are the number root you're finding. Square root, 2 answers. Cube root, 3 answers. Okay? In general, you wouldn't have an 8th root problem on the test, maybe half that. I'd give you a 4th root. Okay? We haven't done roots yet, but when we do, on the test, they'll only go as high as a 4th root. Just because 8th root is kind of time consuming, because you have to find 8 answers. Okay, so any questions on getting the answer in trig form or standard form? Cosine 0? So when I did 135 times 8, I think I got 1,080, something like that. And then I subtracted 360 a bunch of times. And then it eventually came out to 0.
No, but how would you know to stop at 0? Like, why couldn't you stop at like 7?
Because we usually always represent an angle between 0 and 360.
Oh, okay. So you could do 360.
Well, when I say between 0 and 360, I mean not including 360. Yeah.
Wait,
So-
but you can include 0?
Yes, don't include both because they're repeats. 0 and 360 are the same thing, so you wouldn't want to include both.
Okay.
Go with the smaller one.
All right.
But like, you could do like any number between like 0 and 360 and it would still come out to 1.
Yeah, if I hadn't reduced this, if I left it the way it was, I still would have gotten this as the final answer. It's just if you're going to leave the answer in trig form, they are going to simplify it. They are going to simplify it on the test to the smallest angle you can between 0 and 360.
Are you going to have us put it in standard form of the test?
Some problems, yes. Yep. Especially when we get to roots.
So like, wait, so how did you find standard form again?
I did the cosine of 0 times, well, cosine of 0 is 1.
Yeah.
The sine of 0 is 0. And then I just did this arithmetic out. 1 times 1.
All right, that's what I thought. I didn't make sure.
Doesn't always come out to 1s and 0s unless this angle is a multiple of 90.
All right.
Then it will. All right, so in example 1, we've already kind of touched on this. We took a number and we cubed it. So what would be the opposite of cubing? Cube root. So if we took that and we cubed it and got that, then you could take this, cube root it, and you would go back to what you started with. Okay? Or at least that would be one of the 3 answers you could get. Okay? So looking at how would we reverse what we did, we would take a cube root. Okay, so that's what we're going to look at next. Not just cube roots, but roots in general. So this is what we just said. We cubed that, and we got that in example 1. So if you take the cube root of our answer, it would go back to what we started with. Any questions on that idea? Not how to do it, but just the general idea. So now we need to look at how we do it. So as I said, when I explain it without any numbers, just in general, it's not the easiest thing to follow, but once we do an example, that I think will make it a little better. So basically, anytime you're finding an nth root, that's the equation you need to set up. So for example, if I said to you, find the square root of 9, the equation you should be setting up to solve that is z to the second power equals 9. If you can solve that equation that I just put on the board, that will answer my question. What are the square roots of 9? Solve that problem. Okay, so n is your power, or n is your root, and a is what you're taking the root of. Okay. All that this says is both z and a can be complex numbers. Okay. In other words, we're not working with just reals. Z and a can be complex numbers. So the first thing we have to do is rewrite this equation that we just set up in trig form. Now, the left-hand side has to be written in trig form, and so does the right-hand side. The left-hand side, okay, when we write that in trig form, you do the same thing every single time. What I just circled, all you do is replace that with r cosine theta plus I sine theta. Okay, that's all we're going to do every time. So let's see if I can modify this to follow a little bit more of what we're going to do. Okay, so every single time when you set up the problem, I don't care what the power is, I don't care what the number on the other side is, you're going to change z to r cosine theta, I sine theta. Now a, you have to figure out r1 and theta 1. You're going to be given a number, like 9. You have to figure out what 9 is in trig form. Okay, that's what we did last night in the homework. So I'm not going to go through the whole problem, but if I was trying to figure out 9 in trig form, think of 9 as 9 plus no imaginary part. If there's no imaginary part, it's actually easier to do this. Okay? It would be right here. 9 units to the right. What would be the radius? Yeah, whenever you're on an axis, the radius is just how many units you moved. The only time the radius is tricky is if you have a point like that. Then you have to do your Pythagorean theorem. Okay, but the radius would be 9. And what would the angle be for this problem? It would be what? 0 degrees. So if I was doing z squared equals 9, I would be filling in a 9 for r1 and a 0 for theta 1. Okay, I'm not going to fill that in. I'm just going to show it to you in general with r1 and theta 1. Okay, so this would be the equation you would now have set up. Okay. This part is going to look exactly the same in every single problem. And is going to be different in every problem. Depends on what root you're doing. And then the number on the other side, that's going to come, r1 and theta 1 are going to come from the, whatever you figure out, like I did with the number 9. Okay, now, on the left-hand side, okay, what I have right here, I can do this out with de Moivre's theorem. I'm taking a complex number and I'm raising it to a power. So what would I do with my radius and the power? Raise it. So it would be r to the n. And what would I do with my angle and the power? Multiply them. So it would be just like that. In an actual problem, n will be a number. Okay, you will know that number. And r1 will be a number, and theta 1 will be a number. So at this point, the only letters you're going to have in the problem are going to be r, you're going to have a letter here, and you're going to have a letter here, and the same letter there. So the three things that I circled will be the only things in the problem that are not numbers. Now, if you want what's on the left and what's on the right to match, there's two things that have to match. the radius on the left has to match the radius on the right. Okay, that's the first thing. And once you solve this equation, that's going to be the radius of our final answer. So that has to match. And besides the radii, what else has to match? Yeah, the angles. So the two radii have to match in order to put an equal sign there. And whatever you put there and whatever you put there have to be the same.
Why does yeah, well, they have the twos?
Yeah, I've been erasing those as I go. Did I miss any other ones?
R2.
Yeah. Thank you. So now, that angle has to match that angle. Or, what can you add to theta 1 that wouldn't change the angle? Or you can subtract it as well. You can add or subtract any multiple of 360. Or if you're in radians, that's 2 pi. So the angle on the left has to match the angle on the right, or the fancy way to say this is anything that is coterminal with it, meaning adding or subtracting 360. So now k represents an integer. And k is how you're going to get the multiple answers for your problem. So when you're writing all your answers in trig form, every single answer has the same radius, all of them. But what makes them different is you can get different values for theta. Okay, and nth root will always have n answers. So if you're doing a square root, 2 answers. Fourth root, 4 answers. So how do you get the different answers? Okay, what you do is you let k equal different numbers. For example, if I was doing a cube root, the way I would get my 3 answers is I would plug in 0 for k, then I would plug in 1 for k, and then I would plug in 2 for k. There's my 3 answers. If I was doing a 5th root, I would plug in the values 0, 1, 2, 3, 4. That would be my 5 answers for a 5th root. So basically, you just plug in every number up to your root minus 1, because you're starting with 0. Okay, so if you had a 10th root, you would plug in every number 0 through 9. And that would give you all your 10 answers. And when you're plugging in these numbers, it's all going to be very basic arithmetic, because you're not going to have any letters on that side of the equation. It's all going to be numbers. Okay, so we need to just try a couple and see how they work. Okay, and the last thing I don't think I'm going to mention about the graphing. Oh no, that I do need to mention. There is one special term that they use. I don't use the term a lot, but if they ever ask you to find like the square roots of 3, that's the only way to say it. Find the square root of 3. But if they ask you to find the square root of 1, there's a different way to say the number 1. Okay? Sometimes they say the word unity. Okay? If you don't like the word unity, you can just cross it out. Well, don't really cross it out in your book, but pretend like it's not there and put the word 1. Okay? So when you see the word unity, it means 1. Okay, so find the cube roots of unity, find the cube roots of 1.
In the other video, you had that in a different spot.
This is the only video for this section.
How you have you look at the one before?
Yeah, it should be similar. Yeah. Okay. I don't really want to graph. I just want to find the 4th roots of unity. So the first thing you have to do is set up this equation. z to your root equals what you're taking the root of. Z to my root equals what I'm taking the root of. Okay. Next step is to translate the left-hand side and the right-hand side into trig form. What did I say we always fill in for z? R cosine theta, yep, plus I sine theta. Now on the right-hand side, we're not going to have any letters there. Okay? We have to figure out what 1 is in trig form. What's the imaginary part for 1? Yeah, you could think of it, no imaginary part. So that means that this, when we graph it, is going to be where? It's going to be on an axis. So the angle should be easy to find, and so should the radius. It's right 1 unit. So what's my radius? 1. And if I go to the right, what's my angle? 0. All right. Now, rather than rewriting it a whole second time just to do one step, how do I do out the left-hand side with de Moivre's theorem? Raise r to the 4th, yep. And multiply the thetas by 4. Okay, so rather than rewriting the whole thing, I'm just going to do that. Okay, and now we need to set up two equations. This radius has to match that radius. Okay, we'll come back to that and solve it in a second. And this angle has to match that angle, plus we can add something onto the end. So 4 theta has to match 0, which we don't even need to write, but I will. And what can I add onto the end if I'm doing it in degrees? 360 K. And now we need to solve each equation. Let's start with the one on the left. How would you get r by itself here? Take the 4th root, which is the same as doing what? The 4th root, yes, is the same as the square root twice. I'm trying to think of, I want you to think about it this way. What power could you raise 4 to? That would basically cancel it out. Yeah, the 1/4 power. Because when you have a power to a power, what do you do with your numbers? You multiply them. And what's 4 times 1/4? 1. So you just have r to the 1st now. So taking the 4th root is the same as raising to the 1/4 power. Taking the square root is the same as raising to the 1/2 power. Whichever way you want to think about it. But this is going to be helpful for the next problem. So we get r. And what's the 4th root of 1? Or 1 to the 1/4? 1. So in every problem, my radius is going to be 1. Okay, now my angle. I don't want 4 times my angle, I want my angle. So how would I get rid of this 4? Yeah, that, even though this time it doesn't really do much, and that. So my angle is, that's really gone, I don't need it, 0, plus, what's 360 divided by 4? 90. And now I'm finding a 4th root. So how many answers are there to this problem? 4. So what are the 4 values for k? 0, 1, 2, 3. I'm just going to plug in each number one at a time, and those are my answers. Okay, and I'm going to write them all in trig form. So I have 4 answers. The radius in each answer is 1. Leave room for my angle. And leave room for my angle again. Okay, first one. Let k equal 0. What's 90 times 0? 0. First answer. Second, 90 times 1. 90. Third answer? 180. And fourth answer? 270. And that's it. Those are the 4 answers in trig form.
So if that says to like the 20th, we don't have to write all 20 answers.
No, the most you'd have on the test is 4, I said earlier. Yeah, we're going to practice, I think, maybe up to a 6th root or 5th root, but on the test I don't go any higher than 4th, what we just did. Now, if they wanted the answers in standard form, it's a little time consuming, but you just have to type each one of them in. Or if you know the answers, we can do it in our head. What's the cosine of 0?
1.
That's 1. What's the sine of 0? 0. I times 0 is gone. And what's 1 times 1? 1. So one of the 4th roots of 1 is 1. 1 times 1 times 1 times 1 is 1. Okay. What's the cosine of 90? 1. Yeah. What's the sine of 90? That's 1. So we have basically 1 times, we're distributing it, but distributing a 1, doesn't do anything? Let me double check this, hold on. Cosine of 90 is not 1. Yeah, that's 0. Cosine of 90 is 0. So now we're still distributing a 1, but it doesn't do anything. What's I times 1? I. So if you multiply I times I times I times I, you get 1. Think about it. It's I squared times I squared, which is -1 times -1, which is 1. Okay. What's the cosine of 180? Let's see. That would be 0, 90, 180 is -1. Yes. And what about the sine of 180? That's 0. So what's 1 times -1? Which is another 4th root of 1. -1 times -1 times -1 times -1. And anyone have a guess what the last answer is going to be? Yeah, it's going to be -I. So cosine of 270 is 0. The sine of 270 is -1. And then 1, you're distributing it, but it doesn't make a difference. What's I times -1? -I. Okay, so these are the 4 answers in trig form. Those are the 4 answers in standard form. You're not always going to have to change trig form to standard form. You will on, I think, at least one or two questions. Okay. Any questions on that? All right, how could you show that that is, if you were to take the 8th root of 1, there are 8 answers. That's one of them. How could you show that this is an 8th root of 1? I don't want you to find the other 7. Yeah, if you raise this to the 8th power and get, what? 1. It's like if I said to you, prove to me 3 is the square root of 9. Well, if you take 3 and square it and get 9, then that proves 3 is the square root of 9. Take and raise this to the 8th power. And see if you get 1. If you do, it proves that's the 8th root of 1. Okay, and even in radians, I don't think the calculation is going to be bad. What's the radius? Yeah, 1, because the radius in the original is just a 1. They didn't write it. 1 to the 8th power is still 1, so I'm not going to write it. And what about my angle? Two pi, because you multiply the angle by the power. 2 pi divided by 8 times 8 is just 2 pi. And 2 pi is the same as what number? 360, but that's also the same as 0. What's the cosine of 0? 1. What's the sine of 0? 0. You're left with 1. So I just proved if you raise this number to the 8th power, you get 1, which means it must be the 8th root of 1, or it's one of the 8 answers. But we're not finding the other 7. Okay. Any questions on that?
How did you get the 1? Is that from the radius?
Where did I get the
The 1 at the end there.
this one?
Yeah.
So when we did the cosine of 0, that comes out to 1.
Oh, okay. I understand that.
Yeah. It helps if you have the quadrantal angles memorized, or if you don't, if you can picture this in your head, that's sine. Sine of 0 is 0, 90 is 1, 180 is 0, 270 is negative 1, 360 is back to 0. Okay, if you can picture that one and this one in your head. Cosine of 0 is 1, 90 is 0, 180 is negative 1, 270 is 0, 360 back to 1. If not, you can check it on the calculator, just to slow things down a little bit. Okay, cube roots. Okay, it's a little easier than the first one. It's a cube root instead of a 4th root. So we're expecting how many answers? 3. What's the equation that I need to set up? Z to your root equals negative 8. If you can solve that equation, that's the answer to the cube roots of negative 8. Okay, what do we change Z to? Okay, we can do it both at once. Yep, R to the 3rd. Okay, so we did 2 things there. We changed Z to the R cosine theta, I sine theta, and we cubed it at the same time. Any questions on doing both of those at once? Okay, now on the other side, we need negative 8 in trig form. How would I graph negative 8? To the left, 8. So what's my radius? 8. Radius is still pretty easy because you're on an axis. We haven't had to use inverse tangent yet. Cosine of, what's my angle?
180.
180 plus I sine 180. Okay, now what's going to be the equation I set up for my radius? R to the 3rd equals 8. And let's just solve that. So you can solve that 2 ways. What's one thing you could do to both sides? Raise to the 1/3 power, which is exactly the same as taking the cube root. It's the same thing. So the cube root is 2. So in my 3 answers that I'm about to get, that's my radius every time. Okay, I just like to set up my answers. Okay, I'll fill those out in a second. All right, so I got my radius. What's my equation for my angle? Okay, I need an equal sign in there somewhere, though, to make it an equation. 3 theta.
Equals 180.
Yeah,
360.
plus 360k. And now, I don't want 3 times my angle. I would like just my angle. Yeah, so when you divide everything by 3, we're going to get 60 plus 120k. So what are the 3 values that I'm going to let k equal? 0, 1, 2. And now we'll just fill in our answers. So if I let k equal 0, what's my angle? 60. What if I let k equal 1? 180. And what if I let k equal 2? 300. Okay, I'm not going to change those to standard form. I'm going to leave them in trig form. So those are the cube roots of -8. And one of these, I can guarantee you, comes out to -2, if you were to change it to standard form. It has to, because -2 times -2 times -2 is -8. It's probably the second one. Okay, so any questions on that? All right, that's a fifth root. Oh, that's the last one. Okay, so we'll finish up with the fifth roots of 1 plus I. So I've already given you the equation. Can somebody tell me what is going to go, let's see, on the left-hand side? Somebody do it. Yeah.
Okay, so the cosine of theta plus I sine theta.
Okay, we have cosine theta plus I sine theta. One more thing I need there.
The radius.
The radius.
Parentheses.
And what are we doing with all of this?
So the power.
We're raising it to the fifth. So we can either put the fifth here now, or we can just do it out.
Four to the five.
So what would it be if we do it out? Yep.
So it'd be r to the fifth, parentheses, cosine 5 theta plus I sine, is it 5 theta?
5 theta. Okay, so that's the left-hand side. Now the right-hand side. Where is the point 1 plus I? Yeah. It's in the first quadrant. It's not on an axis. So if I make a triangle out of that, how long is the bottom side? And the height? So even though it's on an axis, it's actually still a pretty easy angle to figure out. But let's pretend we didn't know the angle. And you might not be sure of it. So how would you get it if it wasn't two numbers that were the same? Yeah, you do inverse tangent of y over x. And what's the inverse tangent of 1? It's a 45-degree angle. Okay? I'm going to need to move this somewhere else. So we got our angle. And what about my radius? Yeah, it's going to be the square root of 2. So there's your radius. There's your angle. That's what goes on the right-hand side. Any questions on the radius or the angle?
How can you describe it?
Just the Pythagorean theorem with each side being 1 and 1. So it's r cosine 45. Let's just go like this. So we got r cosine 45 plus I sine 45. Okay, what's my first equation I'm going to set up? Yep, r to the fifth equals square root 2. And let's solve it first. Now, a square root is the same as what power, did I just say? To the half. Okay. And I want to think of it that way, because how would I get rid of the 5 here? Raise each side to what power? The 1/5 power. So the reason I did it that way is because now I get r by itself, and I have 2, instead of saying the square root of 2 to the 1/5, I have 2 to the 1/2 to the 1/5. What do you do with these two powers? Multiply them. So what is that? It's 2 to the 1/10. Or if you don't like it as an exponent, what root of 2 is that? It's the 10th root of 2. So if you know that if you take the square root of a 5th root, you get the 10th root, and you don't need to go through writing it as an exponent, that's fine. Just like if you took the square root of a cube root, that would be a 6th root, if you just know 2 times 3. But if you want to write it out as an exponent, that's fine. So there's your radius. Any questions on that? I'm not going to do this out. Okay. Does everybody know how to type a 10th root in on the calculator if you had to do it out? So you type in 10, math, 5th option, and then you can type in the 10th root of 2. Okay? Most of the time, they're not going to ask you to do this out, so you don't need to know that, but it's handy if you ever need to. Okay, so let's write down 10th root of 2 cosine plus I sine. And then in your notebook, just copy and paste that a couple times.
Oh, man.
Oh, you can't? Sorry. Huh, I messed up. I'm being spited.
I wish they were touch screen. I wish the Chromebooks were touch screen.
My answers are very spaced out, but that's okay. All right, so those are going to be my 5 answers, very spaced out. And now what would be my equation I set up for my angle?
5 theta equals 45 plus 360k.
All right. And I'm going to divide everything by 5. It's nice when it goes in evenly and you don't have to deal with fractions. That doesn't always happen, but a lot of times it does. What's 45 divided by 5? 9. And maybe we'll just use the calculator for this one. 360 divided by 5 is 72. Okay. And what are the 5 values we're going to let k be?
0, 1, 2, 3.
Yep, 0 through 4. All right, let's see if we can do the arithmetic. 72 is kind of a weird number, but first one's not bad. What's my first angle? 9. Second angle? 81. Yep. Okay, second angle is going to, our third angle is going to be 144 plus 9. 153. The fourth angle is going to be, yeah, it's going to be 210 plus 2, how much is it? 225. And 297. Okay, so there's all 5 of your angles. Okay, these ones don't come out very nice. But any questions on those? Okay, I want to look back at something we just did when we found the cube roots of this problem. Okay, 1, -1, I, and -I. I want to see if you notice something. How would you graph 1? Right 1. How would you graph I? Up 1. And how would you graph -1? Left 1. And then -I? Down 1. Okay, what do you notice about if you were to connect those 4 lines? Yeah. You get a square, or a diamond because it's kind of turned. What happens is when you find roots, if you graph them, they are always the vertices of a regular polygon. So if you have 3 roots, they would make an equilateral triangle. If you had 5 roots, like we just did in the last problem, they would be the vertices of a pentagon. Okay? Perfectly, every time. So in other words, all the roots are equally spaced. So you could kind of use that to your advantage. If you get 1 root, you can just do the k equals 0, 1, 2 thing. Or if you know they're all equally spaced, you might even be able to come up with an easier way to find all the roots. Okay? But that always happens. So like if you had 8 roots, they would be the vertices of what shape? It would make an octagon. Yep. Yep. Okay, so the homework tonight is page 458, 3 through 5, 8 through 12, 26 to 28, and 35. So we'll take a look at that tomorrow. And then after we look at the homework, we will go over we'll take the test.
Are you doing
Okay.
that?
Yep, I will be after school today for a review.
Are you gonna record it then?
Yeah, if there's enough people, I could put it online. Sure.